Jai Hind to all. Today we start a new chapter, vectors. Actually, this chapter is a simple chapter. So CBSE deleted some portion from this chapter, that is scalar triple product is already deleted. Now this topic contains what is vectors and what are the properties of vectors and the product of vectors. Okay, now we start the class. Today we start a new chapter, vectors. You know, all quantities are classified into two. One is scalar and other is vector. What is scalar? Quantities having only magnitude is called scalar. And quantities having both magnitude and direction are called vectors. What is scalar and what is vector? The concept of this will be learned. Be learned in our last physics class, last year physics class. So here we mathematically vectors are represented using directed line segment. Directed line segment. In mathematics, vectors are represented using directed line segment. This is a directed line segment. Okay, A, B. The point from which a vector starts is called the initial point, and that point where the end is called terminal point. The distance between the initial point and the terminal point is called magnitude or modulus, and is denoted by modulus vector AB. Arrow mark represents the direction and the length of AB is called magnitude or modulus of the vector. Okay, here vectors are represented using direct line segment. The starting point is called initial point and the ending point is called terminal point. The length of AB is called modulus or magnitude. Now we define position of a vector. Position of a vector. Position of a vector. What is the position of a vector? If P, X, Y, Z is any point in space, P, X, Y, Z is any point in space. Suppose you take P, X, Y, Z is any point in space. Then we define position vector of P. That means P is any point in space. Then the position vector of P. But just a point in the space, point just a vector P and represent. And origin, either point in origin connected to vector to convert. That is position vector of P is defined as either vector OP and represent or position vector of P and represent is equal to. Here in 3 axes, you know already in 3 axes, x axis contain I vector, in y axis lies j vector, and z axis lies the unit vector k. Therefore, the position vector of P is defined as a unit vector multiple summate expressed, that is xi plus yj plus zk. And position vector of P is equal to xi plus yj plus zk. Okay. Now we take A and B are 2 points in space. We take A and B are in 2 points in space. Suppose A coordinate is x1, y1, z1 and B coordinate is x2, y2, z2. Then how to define vector AB? Now we connect A and B to the origin. A and B to the origin. Position vector of A with the position vector of B. Here vector AB is equal to position vector of B minus position vector of A. That is equal to position vector of B means x2i plus y2j plus z2k minus x1i plus y1j plus z1k. That's equal to x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. That's the position vector of AB. Okay. A vector A, if suppose you take a P is any point in space, then the position vector of P is suppose the P coordinate is x, y, z, then the position vector of P is defined as xi plus yj plus z. Just a simple ഒരു പോയിന്റ് ആണെങ്കിൽ അതിൻ്റെ പൊസിഷൻ വെക്ടർ നമ്മൾ ഡിഫൈൻ ചെയ്യുമ്പോൾ ജസ്റ്റ് ഐ ജെ കെ മൾട്ടിപ്പിളുടെ സമ്മായിട്ട് എക്സ്പ്രസ് ചെയ്തായി. പക്ഷേ ബട്ട് ഇൻ എ സ്പേസ് ദേ കണ്ട ടു പോയിന്റ്സ് വരികയാണെങ്കിൽ ആ പോയിന്റുകൾ കണക്ട് ചെയ്തുള്ള വെക്ടർ സെഗ്മെൻറ്റ് ഫോം ചെയ്യാൻ സെക്കൻഡ് പോയിന്റ് പൊസിഷൻ വെക്ടർ മൈനസ് ഫസ്റ്റ് പോയിന്റ് പൊസിഷൻ വെക്ടർ ഇപ്പോൾ ഓൾ ഡെവലപ്പ് ചെയ്യുന്ന യൂസിങ് ട്രയാങ്കിൾ വെക്ടർ അഡീഷൻ യൂസ് ചെയ്തിട്ടാണ്. യു ഓൾറെഡി നോ OA plus AB is equal to OB, and therefore AB is equal to OB minus OA. That is OA plus AB is equal to OB, etc. You already know what is triangle, and therefore vector AB is equal to vector OB minus vector OA. This same concept I would use in there. Therefore, just P x y z is any point in space, then the position vector of P is defined as xi plus yj plus zk. And if a 2 point in space, vector A is already given, A coordinate is given x1 y1 etc. and B coordinate is x2 y2 is already given, then vector AB is defined as position vector of B minus position vector of A. Okay, position vector of B minus position vector of A. Next is how to find length of AB, I mean modulus of AB or modulus of OP. You take any vector. Suppose P is a single point in AB. You know AB, A coordinate is x1 y1 z and B coordinate x2 y2 z, which one? Okay, AB this vector AB is defined as x2 minus x1 y plus y2 minus y1 j plus z2 minus z. Now you know vector OP is xi plus yj plus z2 zk, and therefore length of OP, that is modulus of OP, is defined as square root of s square plus y square plus z square. Length of OP is equal to root of x square plus y square plus z square. Similarly, if vector AB, here A and B are already given, vector AB is already x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k, and therefore modulus of AB is equal to modulus value or magnitude of this vector AB is equal to square root of x coefficient square, that is x2 minus x1 the whole square plus j coefficient, that is y2 minus y1 the whole square plus z2 minus z1 the whole square. Now we define some types of vector. Our first vector is zero vector. A vector whose modulus, I mean whose length is 0. Suppose a vector is given and you find modulus value, the modulus value becomes 0, then that type of vector is called zero vector. That is initial and terminal point is same, that is vector AA is a zero vector. Vector BB is a zero vector. Here initial and terminal point is a direct line segment, initial and terminal point is same. That type of vector is called a zero vector. Then unit vector. What is unit vector? A vector whose magnitude or whose modulus is unity. A vector whose magnitude is unity. Then using this formula we find a modulus of vector and the value become 1, then that type of vector is called unit vector. A vector whose magnitude is unity is called unit vector. Then co-initial vector. What is co-initial vector? Vectors having the same initial point, that means suppose a point is given, from this point you write two or more vectors. Vectors having the same initial point, that type of vector is called co-initial vector. vectors having the same initial point is called a co-initial vector. Then collinear vector. Collinear vector. What is collinear vector? Collinear vector. Collinear vector means two or more vectors lie in a same line of action. Two or more vectors lie in a same line of action. That type of vector is called collinear vectors. A zero vector means a vector whose modulus is 0. A vector whose modulus is 1 is called unit vector. Two or more vectors, vectors having the same initial point is called co-initial vector. Two or more vectors lie in the same line of action is called collinear vector. Suppose vector A and vector B are any two vectors. The concept of collinear is similar to the parallel vector. That is, if suppose vector A is given and vector B is another vector, then vector A can be expressed as a constant multiple of vector B. If vector A and vector B are collinear, then which is expressed as a vector A is equal to a constant multiple of vector B. Parallel same concept ആണ് നമ്മൾ collinear നമുക്ക് യൂസ് ചെയ്ത് പോകുന്നത്. ഒരു വെക്ടർ മറ്റൊരു വെക്ടറിൻ്റെ ഒരു മൾട്ടിപ്പിൾ ആയിട്ട് എക്സ്പ്രസ് ചെയ്യാൻ പറ്റിയാൽ then the vectors are said to be collinear. Then coplanar vectors. Two or more vectors lie in a same plane, then the vectors are said to be coplanar vectors. Two or more vectors lie in a same plane are called coplanar vectors. Two or more vectors lie in a same plane are called coplanar vectors. Now define unit vector in a direction of a vector. Now define unit vector in the direction of a vector. That is, vector A is any vector. If vector A is any vector, then the unit vector in the direction of a vector. Suppose vector A is, you take A to B. It is a direct line vector AB. Vector AB is also expressed as suppose vector A. ഇങ്ങനെ express ചെയ്യാം. Small letter use ചെയ്ത് നമുക്ക് vector A represent ചെയ്യാം. അല്ലെങ്കിൽ or capital AB. That is, capital vector AB is also is equal to small vector A. Okay. So, vector A is any vector. Then the unit vector in the direction of vector A. Unit vector in the direction. Unit vector in the direction of vector A is expressed as n cap. Unit vector is represented by the symbol n cap is equal to vector A divided by modulus of vector A. Vector A divided by modulus of vector A is also another point. Unit vector in the direction of vector A is expressed as n cap. Unit vector is represented by the symbol n cap is equal to vector A divided by modulus of vector A. Okay, these are some basic points regarding the chapter vectors. Now we define now discuss some problems based on this base concept. Okay, our first question: find a unit vector in the direction of vector A is equal to I plus j plus 2k. Vector A is equal to I plus j plus 2k. Find the unit vector in the direction of I plus j plus 2k. You already know unit vector formula is n cap is equal to vector A divided by modulus of vector A is equal to I plus j plus 2k divided by, you know the modulus formula, square root of ijk times in the square root of sum. That is, I coefficient times in the coefficient of the square root of sum. Here the I coefficient is 1 square plus j coefficient is 1 square plus k coefficient is 2 square is equal to I plus j plus 2k divided by root 6 is equal to I by root 6 plus j by root 6 plus k divided 2k divided by root 6. Okay, suppose we find the modulus value of this vector, we get answer 1 because it's clearly unit vector. I plus j plus 2k is any vector. ആ സെയിം വെക്ടറിൻ്റെ ഡയറക്ഷനുള്ള ഒരു യൂണിറ്റ് വെക്ടർ ഫോം ചെയ്യാൻ പറഞ്ഞാൽ വെക്ടറിനെ അതിൻ്റെ മോഡുലസ് വാല്യൂ കൊണ്ട് ഡിവൈഡ് ചെയ്യുക. Now second question, find a vector in the direction of vector A is equal to, find a vector in the direction of vector A is equal to 3i minus 4j that has magnitude 9. Here k time is 0. 3i minus 4j that has magnitude 9. That is A is any vector അതിൻ്റെ അതേ ഡയറക്ഷനിൽ 9 മാഗ്നിറ്റ്യൂഡ് ഉള്ള ഒരു വെക്ടർ ഫോം ചെയ്യുക. If suppose vector A is any vector, A is any vector. There is just initial and terminal point, that's all, any point. A is any vector. We form ഈ സെയിം ഡയറക്ഷനിൽ 9 മാഗ്നിറ്റ്യൂഡ് ഉള്ള ഒരു വെക്ടർ ഫോം ചെയ്യുക. First of all, you find the magnitude of this vector. Mod A is equal to square root of 3 square plus 4 minus 4 square, that is 16, is equal to square root of 25 is equal to, we get answer 5. This magnitude is 5. നമുക്ക് ഫോം ചെയ്യേണ്ടത് 9 മാഗ്നിറ്റ്യൂഡ് ഉള്ള യൂണിറ്റ് വെക്ടറാണ്, 9 മാഗ്നിറ്റ്യൂഡ് ഉള്ള വെക്ടറാണ്. So first of all, we find the unit vector in the direction of this vector A. That is n cap. You know the formula n cap. Vector A divided by modulus of vector A. That is 3i minus 4j divided by mod A is already find 5. That is equal to 3 by 5 into I minus 4 by 5 into j. That is unit vector. Now we find a vector whose magnitude is very important question, is 9 unit. The direction of 3i minus 4j is equal to, is clearly a unit vector. നിങ്ങൾ യൂണിറ്റ് വെക്ടറിനെ 9 കൊണ്ട് ഇൻറ്റു ചെയ്താൽ, that is 9 into 3 by 5 into I minus 4 by 5 into j is equal to 27 divided by 5 into I minus 36 divided by 5 into j. We get the modulus value of this vector become 9. That's all. First of all, you convert a given vector in a unit vector, then multiplying by 9. That's all. Suppose another question, find a vector in the direction of vector A equal to I plus 2j plus 3k and use magnitude is 10 unit. Similarly, we can find. First of all, you convert the given vector as a unit vector, then multiply by that constant, that quantity, that is 10 or 11, any number. Okay, it's a very important question. Okay. Now the third question, if vector A is equal to, our third question, vector A is equal to 2i minus j plus 2k. Vector A is equal to 2i minus j plus 2k. Vector B is equal to minus I plus j minus k. Find a unit vector in the direction of A plus B. Find a unit vector in the direction of A plus B. Also find a vector in the direction of A plus B which has magnitude 5 unit. Also find a vector in the direction of A plus B which has magnitude 5 unit. Okay, first of all we find A plus B. You know A plus B? A plus B means sum of the vector. Sum of the mean corresponding terms add here. That is 2i minus j plus 2k plus what is vector B? Minus I plus j minus k is equal to, you know, 2i minus I is I, minus j plus j is 0j, 2k minus k is plus k, that is A plus B. Now we find the unit vector in the direction of A plus B. That is n cap is equal to vector A plus B divided by modulus of A plus B is equal to I plus 0j plus k divided by square root of 1 plus 1 is equal to I plus k divided by root 2. Now a vector. Now you find a vector whose magnitude is 5 unit in the direction of vector a plus b is equal to, in the same direction, a plus b എന്നുള്ള വെക്ടറിൻ്റെ അതേ ഡയറക്ഷനുള്ള 5 മാഗ്നിറ്റ്യൂഡുള്ള ഒരു വെക്ടർ ഫോം ചെയ്യാനാണ് പറയുന്നത്. and 5 കൊണ്ട് ഇൻറ്റു ചെയ്താൽ മാത്രം മതി യൂണിറ്റ് വെക്ടർ. ദാറ്റ് ഈസ് 5 into I plus k divided by root 2. That's all. Now we find the modulus value of this vector, we get answer 5. So it's a very important question. Okay. Now show that vector A is equal to 2i minus 3j plus 4k. 2i minus 3j plus 4k. Vector B is equal to minus 4i plus 6j minus 8k are collinear. How to find the collinearity of this vector? You already know the condition collinearity. Collinear means two or more vectors lie in the same line of action. Okay, here these two, we have to prove that these two vectors are collinear. Collinear condition multiply and prove it. Here A is equal to 2i minus 3j plus 4k. Here vector B is equal to, here take a minus 2 as a common term, minus 2 common select, but we get answer 2i minus 3j plus 4k. That is vector B is equal to minus 2 into vector A. That is vector B is equal to a constant multiple of vector A. That means therefore we get vector A and vector B are collinear. Vector A and vector B are collinear. That's all. Now A 1 2 4, A coordinate is already given 1 2 4. B 2 minus 1 3, B 2 minus 1 3. B 2 points, find vector AB, and unit vector in the direction of vector AB. Also find unit vector in the direction of vector AB. You know, when 2 points are given, using the 2 points, how to find the vector AB? You know, position vector of P minus position vector of A. Here 2 points is given, 2 points coordinate is position vector define. Position vector B minus position vector A, we get vector AB. That is equal to, now position vector of B means 2 minus 1 3 is converted to vector form 2i minus j plus 3k minus position vector of A means I plus 2j plus 4k is equal to 2i minus I is I, minus j minus 2j is minus 3j, 3k minus 4k is minus k. Okay, I minus, we get answer 2i minus I. 2i minus I is I, minus j minus 2j minus 3j, 3k minus 4k is minus k. This vector AB is equal to, we get answer, vector AB is equal to, we get answer I minus 3j minus k. Now we find the unit vector in the direction of vector AP, that is n cap is equal to vector AB divided by modulus of vector AB is equal to I minus 3j minus k divided by square root of ijk terms in the coefficient of the square sum 1 plus 9 plus 1 is equal to I minus 3j minus k divided by root 11. That's all. Okay, it's very important question. This type of questions are very important type questions. Okay, now you define the position vector of a section using section formula. That will be discussed later. That's all today's class. On next video we define product of vectors. Okay, bye.